I'm going to draw a picture of what's going on in memory to help make sense of it while I act as a virtual debugger here. So set a breakpoint on this line, hit debug, it stops right here. The code is now executing on this line, wrapper W equals new wrapper. Here's what actually happens. This little bit of code right here, wrapper W, creates a variable, which I will indicate with a box. And I'll put the letter W here next to it to say that's the name of the variable. And this code right here makes a new wrapper. And we'll show a wrapper object with a slightly bigger box. A wrapper in it has a variable inside of it named I.
Where did you get that?
Now the reason I knew that is because right here I declare my class wrapper.
Okay.
And wrapper right here has a member variable in it named I of type int. Now a class is like a template that describes what the objects will look like. This box I drew right here represents the object that I have just allocated when I said new wrapper. So new wrapper creates this object, which is big enough to hold a variable named I, because that's what the template says all wrappers look like. I could have allocated 12 wrappers if I wanted, in which case whoops, wrong button. I would have 12 of these laying around, and they would all have eyes. But I only called new one time, so I only allocated one object. And as it happens, this equal sign right here says that the thing that's going to go in this box is actually a memory location. So I don't know what number it is, but it's some number that represents where in memory that other object is. Another way to draw that pictographically is with an arrow. I kind of prefer that mechanism. So what's actually stored in W, this variable of type wrapper, is a memory location, and it's the location of that new wrapper object that I just allocated right here by saying new wrapper. Okay, another way to put it is W is a variable. Variables reference objects. This wrapper object contains one variable named I, which is an integer. Okay, we have just stepped over this first line and we're now on this line. Right here where I say equals 5, what this actually does is it creates a default constructor and it says I equals 5 in that constructor. And so when I said new wrapper, it calls that default constructor and sets the value of I to 5. I'm using a little bit of shorthand here and I probably shouldn't have done that. But yeah, there is a 5 in the box for that I. Okay. Now, and thank you for pointing that out. That would have made my next step not work if I hadn't put that 5 there. So I'm right on this line, and I call w.inc. Notice that I'm putting the object name before the method call instead of inside of the parameter list. That's how you do it. Can't really say why. It is passed just like a parameter, and again, that's something I still need to talk about. But long story short, we're going to call this method, and we're also telling it that, hey, we're calling that method with this object. Because you really have to have an object to call a member method. Well, this is a call, right. W.inc, and it's going to call whatever has that name, and that method has that name. So this line right here, because it says inc parenthesis, that means go to here. Yes. So think of it as it's going to call this method while having this object, this wrapper object is going to be the thing of focus. Another way to put it is this. And we'll talk more about what that means, but at the moment we're calling inc, this is the object, and not any of the other wrapper objects that could be littering your memory. It's this one that we're talking about.
When you did the picture, w.I, okay, that bottom w.I?
Right there, yeah. This line that we haven't yet gotten to. Yeah. Okay. So we're still on w.inc, and I'm going to do a step in. So now I'm up here. Okay. And it says I++. Well, remember there could very well be other wrapper objects in memory. There's not, because this code only made one. But if there were, how would it know which I to increment? Well, it's the one that I'm talking about. It's this one that we use to call the method. So this I is the one that's going to be incremented. And so what will happen is that I will become a 6. Bink. It has now been incremented to a 6, and we are now on this line, which means return. And it's going to return down to here. And now we're going to system.out.println w.i. So we start at this w, and the dot basically means follow the arrow, or go to the memory location referenced by that variable. So it's going to follow it up to this object, and then see the I. So w.i basically is a reference to this variable. And it's going to print the number 6, and so that is the answer.
And it will stop there.
Then at that moment, it moves on to the next line, which is right here, and that means return. And because this is the main method, it's done with the whole program. So this is the end of the program. It has printed your 6. All done. Game over. Yes. So we have just visually debugged that code. We could easily paste this into NetBeans and step through it ourselves and actually debug the code. And we should see exactly that same behavior. And in fact, would that be good practice? You wanted to give it a try? How about I just do it for you, because I bet I could do it faster than you can. And I think it would be good to see that, in fact, the things I'm saying are not just made up. That's actually what the machine does. So I'm opening NetBeans. And remember when computers used to be fast? I typed in a math problem into my Atari 800 XL in 1982 or whenever that was. Pressed enter, and it already had the answer faster than I could think. And I thought, wow, it's so fast. And now we slow down our computers with graphical displays and all kinds of this stuff. All right. You're right. They've never been faster than they are now. So, class wrapper. There we go. I have now pasted my code here, but I pasted it on top of yesterday's project, which was called Shapes. I'm going to rename this to Shapes just because otherwise it'll yell at me, and I don't want to bother doing it right. So, I build, see if this works. Come on, work for me. Did it. Okay. Let's run it. Hey, it did say 6, so at least we got the right answer. But now let's see if we can actually watch the details. I put a breakpoint on, let me get rid of that breakpoint. So I have one breakpoint on line 17 where it says wrapper W equals new wrapper. I'm going to hit my debug button. It starts debugging, and here we are. Because it changed to green, that means this is the current point of execution. We're on that line. Now, I could have broken this up into multiple lines, and it would have been easier for us to see exactly what's going on if I did. But this is good enough for right now. Let me look at my variables. Let's see, there's something called static, and there's something called args. What is args, by the way? See how there's a parameter here to main called args? Turns out when you start a program, you can pass to it a bunch of arguments or parameters, and they come in the form of strings, and that's what that's there for. Most of the time I don't use it, so I just almost always ignore this parameter, but it has to be there in main. So again, this is just appeasing the compiler so it can make my darn program work. If you actually want your program to respond to command line parameters, you can use that. So this is the only thing in memory right now is args and static, which we'll talk about a bit later. If I do a step over, push my button, there's now something new in memory, something called W. What is that? Well, it's a variable, Remember when I drew my picture right here, there's this variable w, and it refers to an object of type wrapper. Let me get rid of this one. And okay. Well, if we look in our debugger at variables, we see a w right there. And if I click on the little symbol to the left of it, this is the open or close it, you see that w actually has inside of it something called I, which is of type int. W has a type of wrapper. See how every variable has to have a type. And that integer has a value of 5. Okay. Why is this line red? That's my breakpoint still sitting there. Why is this line green? That's the indication that this is where the program has stopped. This is the finger in the recipe. This is where it is right now. I think it's technically called the instruction pointer or something like that. So the computer is at this moment, and I'm looking at my memory, and I see that w.I has a value of 5. Now, I could do a step over. If I did a step over here, it would just increment I. The w.I would change to 6, and we'd be done. But I want to actually step in, so I'm going to do a step in now. And you see how it jumped up to here? Okay. That's because I stepped in. That's what step in does. And notice that in my variables window, there's a new variable called this. We've not talked about that yet. What is this? Well, that's what I wrote over here in my diagram because I was anticipating this. This is the object that we're talking about, that we're in right now. It's the object. Well, what it really is it's the object associated with the class that wraps the method that we have called. Let me put that a different way. See how we called w.inc? Well, w is passed as sort of an implicit parameter to the inc method. So that when we say I++, which I are we talking about? Well, it's the one inside of w. So when we're right here, w is this. Or rather, this is a copy of the memory location that was previously stored in w, to be technical. And if we open up this, we see that this has a type of wrapper, and it has a member variable named I, which is of type int. There was another walkthrough of how this stuff works. And we're going to talk through it again because I kind of need to rub in some of these principles. Okay. Questions? This is where I declare w, right here. Wrapper w. Yeah. So w is the name of the variable.
Okay.
Wrapper is the type of the variable.
Okay.
A type.
And that goes back up to your class?
Yeah, so a type basically says what this is allowed to point to. So this w is not allowed to point to doohickeys or objects or widgets or cats. It's only allowed to point to wrappers.
Only to the wrapper.
Yeah. Now there could be another wrapper in memory. We can have any number of wrappers. If this was a wrapper,
Right.
w could point to that one.
That's what I didn't get.
Okay.
You said there could be 12 of them on there.
There could be, yeah.
But would they all have 5 in them?
Initially, yes,
Okay.
because when you make a wrapper, it starts with a 5 in it,
Right.
according to this code. So if I made 12 wrappers, they'd all have 5 in them.
To start.
Yeah, to start out with.
Okay.
But if I started incrementing them, it wouldn't go visit all 12 of them and change their eyes. It would only change the one that is this. It's the one that I use to call increment.
Okay.
So I could
And that's where the void INC comes in.
void. I don't see void. Oh, this method. Yeah, this method is what I use to increment my eye. The void means that this method doesn't return anything. It just does a job. And when it's done with its job, it returns without telling me a number back. And its job was to change the number that's inside of the wrapper, that I.
Okay, I understand that.
Okay. Thank you for taking the time to understand the code, because that's what I really want. I want everyone in this class to look at this code and start saying, I get what this symbol, I get why that symbol's there, and this one and that one. I want you to get the whole thing, except for the symbols I've kind of skipped over. We're going to go to those later because I don't want to overwhelm you. But everything in the code I think you get. Let me just talk you through it one last time. This is a type or a class name. Here we're declaring a variable, wrapper W. Here we're allocating this object. Here I'm making that arrow from W point to the object. Here I'm using the object that W references, that object on the heap, to call the inc method, which increments the I inside of this object. And when it returns, and that should be a capital S, I print w.i. w.i means that I, that 5 right there,
Has now changed.
which has been changed to a 6. And so it prints the number 6. Okay, this is a classic example of pass by reference. The reason it's pass by reference is because I'm passing this W to become this when I call inc. And because W is not a primitive type, it's a class type. It's the reference, meaning that it's the memory location, which is stored in W of that object, that's actually passed to the inc method, which is what does all of the job. So, if code this small can be that complicated, how can you possibly understand code that's 100 times bigger? Because it's just repeating the same stuff over and over and over and over. You just got to get used to this, and then all of a sudden you'll start to realize it all makes sense. Kind of, hopefully.
You're going to have to do that on all the rest of stuff you're doing.
Yeah, and I know I keep saying that, and it keeps getting more complicated, but there really is an end to this. It's just the end is not 1 week away. It's a whole lot of time on your own tinkering with it away.